So in this video, we're going to talk about series. So let's pretend you have a sequence of numbers and call it a n equals 1 over n. This is a sequence because for every an, we have one distinct value of 1 over n, right? And so a1 would equal to 1, a2 would equal to half, and a3 would equal to 1 over 3, and so on. Now, if we were to take the sum of all the numbers in the sequence, we would call that a series. The sum of numbers and what we're particularly interested about with series, so first of all, the summation of a bunch of numbers is this funky looking backwards or forwards E sign, or backwards E. This is a backwards E, a funky looking backwards E, where we write n equals 1. So this is the first term that we're starting to add from, and then we can write 1 to 4. So then this would mean that we are adding the first 4 terms of our sequence. And so, for example, if we have sum of n equals 1 to 4 of 1 over n, that means we have a1, which is 1, plus a2, which is half, plus a3, which is 1/3, plus a4, which is 1/4. And this will give us some finite number. So there's nothing particularly interesting about this sum as of this point. But now imagine, instead of summing to a finite number, imagine we take the sum from n equals 1 to infinity of 1 over n. So now we're going to add an infinite number of numbers together. And now we want to know, does this infinite sum go to a finite number? Does it oscillate between two numbers or more, or I guess 2 or more numbers? Or does it just continue to increase unbounded? So does it continue to increase infinitely? And this is really what we're interested when we take the sum of a series. That's when we take the sum of the values of a sequence that are going to infinity. When it sums up to a finite number, we call this convergence. And when it oscillates between numbers or increases infinitely, we call this divergence. So let's start with just this example that we're working on. And now we want to know if this particular series converges or not. So what do we start with? Why don't we just start by summing up a bunch of numbers? So if we take the sum of n equals 1 to infinity of 1 over n, this becomes 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8, and so on. And I guess you may be thinking, like, take the sum of all these numbers. And one of the tricks that, well, not tricks, but one of the methods that we employ is we compare the sum of these terms to a sum that we already know. So in this case, we're going to compare certain terms to the value of half. So obviously we know that 1 is greater than half. It's greater than half, greater or equal to half, right? And half is greater or equal to half. And 1/3 is less than half. But 1/3 plus 1/4 is, we know that this value is also greater than half, right? Because 1/3 is greater than 1/4, and 1/4 plus 1/4 is 1/2. And then 1/5 is less than 1/4 and 1/3 and 1/2. But we know 1/5 is going to be greater than 1/4, because 1/5 is greater than 1/8, and 1/6 is greater than 1/8. And so we know that we have at least 1/8 plus 1/8, which gives us 1/4. And then 1/7 plus 1/8 will also give us a number greater than 1/4. And so 2/4, two numbers that add up to be at least 1/4 each, when you sum these four numbers up, we get greater than or equal to 1/2. And then, so this is with four numbers, and then the values from 9 through 16. 9 through 16. Yes, from 9 through 16 will produce the values from 9 to 16, 9, 10, 11, 12, 13, 14, 15, 16 will produce 8 numbers that are each greater than 1/16. And so 8 numbers, if they are each greater than 1/16, then in total they will be greater than 1/2. And we can do this for all the numbers preceding. And so what we end up with is, we know that the sum of n equals 1 to infinity of 1/n is going to be greater than half. And we have an infinite number of halves, right? Because we have an infinite number of numbers that we can add up to. So this will be greater than 2 times infinity, or greater than half times infinity, which we know is a number that will increase to infinity, because half of infinity is still infinity. So it'll kind of increase unbounded. And so we know that this series is diverging.